little bit about who I am, and I think most of you know me. Soraya, you not, and perhaps Lucius. I've spent a career on the technical side of safety and health and environment, like 25 years in mining and energy and chemicals businesses. So I've done that, but in my undergrad studies, I did have industrial psychology as well, and I realized halfway through my career that the science and technology is not going to cut it. Behavior is just as important to achieve our objectives. And that's why I started this study. My ultimate goal is to get to a socio-technical model where I'm combining social and technical issues into one model. Quite a brave attempt, I realize, after 3 or so years, but I keep going because I believe that is a major opportunity from a research perspective, and I'll show you why. Secondly, those of you that perhaps think safety is more or less sorted, you're right to some extent, but we've had some massive incidents in the last 10 years. And the ones that you know, probably the Deepwater Horizon in Texas, that was in 2010, the drilling platform that sunk eventually, the Fukushima incident, nuclear 2011 in Japan, and the Boeing 737 MAX that was grounded now for 20 months. I believe they're slowly getting back into operation again. These are 3 examples of major incidents. That Deepwater Horizon is the biggest environmental disaster ever, which is a bit surprising if you consider where we have come to safety management and how well we've progressed. And I hope in this presentation to give you some insights, because the common finding in all these incidents tend to be now a finding that says something is wrong with the compliance culture, or there's a wrong safety culture in the organization. That's why the incident happened. Even the Boeing 737 MAX that got grounded, they're now saying, yeah, the design of that aeroplane was done in a rush. There was lots of pressure to get it done quickly. And due to those sort of factors, that is why these incidents started occurring. So that is where I'm coming from. We've made lots of progress, and now we're hitting a new stumbling block, and that is what I'm going to talk about and see if I can end up with a socio-technical model. I said I'm going to talk real life as well, so let's take Mr. Man here as an example. Mr. Man could be Mr. Mangosuthu or Mr. Manchester, or whichever your favorite team is. But he's working in a South African mine today. He's very aware of the dangerous environment he's entering. He's very proud of his job. He's well trained. He's typically got 16 years of experience. So that is an average time that people have worked in a typical chemical plant, in a mine in South Africa these days. 16 years is a lot of experience. So you would think nothing can go wrong anymore. It's done all this training. It is a dangerous environment, but we've put these things in place, so everything should be fine. So what have we done? In the last 50 years, we've built these 3 bubbles. Firstly, the structures, then the technologies and all the regulations to make that Mr. Man safe in the workplace. The structures are the managers, the leaders, the authorities, the workers. There's a whole hierarchy there. The technologies, we've got more and more technologies like alarms, automation, artificial intelligence. In fact, we're reducing the workforce numbers, and we're replacing them with more and more of these technologies to manage safety. And then, of course, we've got a lot of regulations, and especially in safety and health and environment, there's been an explosion of regulations. It's a bit of a nightmare. And these 3 bubbles, of these 3 things that we've put in place in our management system, they're sort of floating on a culture in the organization and people that are actually there. It's floating on top of the nature of the risks we're managing, like Fukushima was a tsunami. Fukushima is interesting because right next to that plant where we They're still struggling with nuclear water that we need to, or radiated water that we need to get rid of. There's a nuclear plant right next to it that did not get damaged. The technologies worked perfectly fine, but it boiled down to the way it was designed by the process safety design engineers. That was the final type of findings. They underestimated the height of these tsunami waves. So nature hits us, but then if we're efficient and effective, we can use technologies, regulations, and structures. This is what we see on paper. You can show on paper what the structure looks like, the technologies, and the regulations. What we do next is then we expect certain behaviors to emerge from that. We're expecting, let's take it from the bottom up here, compliance to all these regulations. We expect good communication should be happening. Awareness of the situation you are in the workplace all the time. Commitment, management, leadership. Many companies will say, my chief safety officer is the CEO. That shows good commitment from the top. That is how, according to the book, we should behave. And this has been the focus of safety management for decades. So Mr. Man walks into this mine, he must start work, and now he's faced with 800 procedures. Because over the last 30 years or so, every time there's an incident, you create a new procedure, you put in more technologies, make sure there's all the safety watches and structures to make sure this Mr. Man won't do that and that incident won't happen again. There's also a lot of alarms that he has to respond to. Like in the Boeing 737 MAX, we're talking about 52 alarms that go off when that plane goes down. So my feeling is that we're sitting here with a bit of an overemphasis on technologies, and in the fourth industrial revolution, we're going to see more and more of that, of reliance on technology, structures, and regulations. And therefore, we need to start considering what else can be done to reduce these incidents and from happening. So what is now interesting is this is a meta-analysis was done in the construction industry of all the literature and all the journals, articles that appeared about construction safety. Construction is one part of safety, and of 935 articles, 101 were specifically empirical articles on safety behavior. And you can see what has happened in the last 5 years or so, a massive increase here in publications on safety behavior. So behavior has become a big thing. It's interesting because the industry, when I started my career in 1990, you can see there were 1 or 2 papers, and it's now sitting at 100. In those days already, it was recognized behavior is important. Being engineers and scientists, we go back to the technology type solutions. We don't really give attention to behavior. And that is why we see now this major interest in safety behavior. This meta-analysis, the whole factor analysis, found 5 important groups. One is the individual, other one is the group where it interacts in. The workplace design is another bunch of papers that come out in that area of work, how the organization is structured and organized. And then lastly, the family, the industry, the society where this organization resides in. That is now also becoming interesting. So on this graph, the blue bars are the total number of articles on safety behavior. The red ones is a new field, and that's where I'm focusing on, is the antecedents of safety behavior. What causes those behaviors to happen? For example, most surveys will look at compliance in the workplace or communication in the workplace. And you ask the employees and they either know they should communicate or they don't know. What is causing that sort of behavior? These antecedents is becoming now interesting here. So for Mr. Man in South Africa, he's paying the bills for his parents, for his brother's children, his own children, his family. HIV/AIDS and COVID hasn't helped here. And we're sitting in a situation where an employee in a mine, for example, has got a huge responsibility towards the family. That influences how you behave in safety world. And I will show you how. So here's another picture showing the culture, the nature of our businesses and where we're situated. And what we then did is we, in this massive safety system of structures, technologies, regulations, and we know according to the book how you should behave. And then we hope to, by doing this, we'll achieve the safety outcomes here at the back, at the right-hand side, the near misses, accidents, injuries, fatalities. If you do all of this, you should have very few of these things happening. You see there's a gap there, and that's my number 2 and 3 topics. So number 1 here, safety system, I modeled that first. And I got my idea from this author, Hodson. He looked at the culture in the workplace and used the Hofstede dimensions. There's about 6 of them, and said 3 of them are really important for safety. And let's just focus for now on that first one, power distance. The distance between the worker and management. In many organizations where that is very large power distance, for example, there's lots of hierarchy and lots of levels of jobs between you and the next person. That has got a negative impact on the whole communication speed. It slows down communication. Also, the accuracy of communication is negative. So you can see he started plotting these things as being either positive, negative. And in some organizations, you've got a very flat structure. So that power distance is very short, where communication speed is obviously then very effective and fast and accurate. So this gave me the first few ideas, because this is contributing to that socio-technical system performance and how this team performs from a safety perspective, as one of them. So I used, for example, on communication, I built a little model using NetLogo for this. And this is the gray world here, where the red block is the control room. You've got 6 machines operating here. And in the control room, you've got the supervisors, let's say in yellow, and the workers. And you can, this model, of course, then build in workers, some of safety supervisors, others are the engineers and the technicians. They keep these 6 machines running. And this is centrally controlled from the control room. In my model, if you look on the left here, if I optimize and have the maximum number of supervisors, you've got lots of employees per machine, everything is done perfectly, and there's no communication. If I take my sliding scale to communication there to 0, you can see that on the right-hand side, the durability of these machines are very variable. It is not reliable at all. And you have accidents happening and incidents happening all the time. So in Mr. Mann's case, if you ask in a questionnaire what communication is like about safety, you will say, no, I never get adequate communication. And that's quite easy. If you run that same model and you move your sliders here, where there's a lot of communication happening, you can see the machines become much more reliable, and there's no accidents or few accidents happening, depending on how long you run this model. So I modeled this little world of mine using the typical safety system, and that describes one of the variables, communication. And I've built some similar models using decision-making, compliance to rules, and other variables. If you ask Mr. Mann, he'll say, in this case, no, he always gets a lot of communication. And this already points us to the limitation of the 5-point Likert scale, where you're saying, do you receive adequate communication? And the box here will tick is probably usually or always. It's not well formulated, this type of question, because in the safety world, what's starting to happen, there's too many alarms, there's too many reports, there's a complete information overload. And eventually that can start to cause incidents again. But we can't see it on this normal Likert scale. So I'll get back to the scales a bit later again. I showed you here the safety system we've built and how I try to model that. Very recently, a new variable became apparent, and those are the objectives that the organization has put forward. It's interesting in the risk world, meeting organization objectives is the purpose of risk management is to help organizations meet objectives. It causes also a lot of pressure, time pressure to produce, to profit, to perform. There's bonuses and incentives, there's fines and penalties. So my next attempt was to say, okay, we don't have a perfect safety system here. We have pressure to perform. How will that influence my model and my model results? And only in the last 2 years, a number of papers have started appearing about the importance of this work pressure. You and I all know we're under pressure to perform. And for the first time, we're not only seeing the safety system here, and number 1 here on this table 4, or competence or leadership, also see work pressure. And what's interesting is this negative correlation. So what latest studies don't only show a positive and negative, like Hodson, it also gives some weights to them to show which ones are more important and which ones are less important. So work pressure, which is number 2 here, you can see influences all of the other variables and constructs. So your safety system, despite all your efforts to put that in and run it as good as possible, more pressure you apply, the less effective that system becomes. And this is quite interesting because this counters all the efforts we're putting into our safety system, our leadership and our competence and our training. You get to the real world and you start working, you're under pressure and you don't perform because you've got this work pressure. I just mentioned there's 2 other studies. Sorry, let me just show this one here. The bottom is from who? He also, these authors distinguish between deep compliance and surface compliance. And what has happened in safety, there's a lot of surface compliance. It is ticking the box. Deep compliance is really understanding why should I do these things differently. And what they also did in this study, which I found quite exciting, that they linked it to the accidents, near misses, and injuries at the bottom here. So the correlations between all these variables, including compliance, for example, and commitment, link that to the eventual safety outcomes, which you'll be surprised, more than 95% of papers, they publish work about the system, the safety system, but they never link those results to the outcomes, like the incidents and accidents, which is really surprising. And the latest research is starting to go that way. It's trying to link all this hard work we're putting in on technology and systems to link that to actual outcomes and actually make it safer. Because if you don't achieve that, then you actually haven't achieved your objective. So yes, I tried to model this one, of course, as well. I used the production target here for how much coal do you want to get out of your mine. On your right-hand side here, you see a mine. This little black dots, this is your automated miner. And this miner goes through the mine. It leaves little pillars, these yellow and red dots. And the miner goes through the mine, and the shuttle car then takes that coal out of the mine into the conveyor belt to the surface. And this little miner, this is Mr. Man driving either the miner or the shuttle car, is trying as hard as possible and quickly as possible to get the coal out of the mine. So this live model, when it runs, and I'm not going to go online now to show that, goes up and down through this mine, takes the coal out. Then I can set my variable. So what I've done is here, I've in one case set the production pressure to low, and another one I've set the production pressure set at very high to see what the results are. And on the next slide, I've enlarged this for you, so I keep all the other variables the same. And now you have production pressure set on low. You can see here your coal production is quite high, and the casualties are there, but they are lower than in the case where the coal production pressure is very high, where there's lots of pressure to produce. Because at some point, and this is now the extreme case, of course, you get lots of casualties, more than double what you will find in a normal operation, because of the huge pressure to produce more coal. In fact, the coal production starts to decline because every time there's a major incident, like a fatality, the whole shaft has to shut down, and you can't produce, and it takes a day or two for the investigation to finish before you can start mining again. So eventually coal production also suffers. And in these models, you can then use all hybrids of these different extremes of pressure that you apply in the mining setup. So I showed you the safety system. I showed you the impact of pressure and what that does on performance, on safety. And the last part I want to show you is the actual behaviors, because what we now realize is that according to the book, you should comply. You should be doing all these things. In actual fact, when you're under pressure, you behave quite differently. So on the next slide, I've enlarged this a bit. And if I can show you here, for example, in the workplace, when things start going wrong on an oil drilling platform or in an aeroplane, in the cockpit, you want your workers not to be reckless. That's on the one extreme. You also don't want them to be cowards and run away. If it's a small little fire, you want them to kill that fire immediately and move on. So you need a level in between, some controlled fears. My previous slide, that model on the pressure to perform, is a good example of these balanced priorities. You don't want a push for production only, because then safety is going to suffer. You also don't want safety only. If you just don't want to do work safe, you're not going to do any work at all. And you are 100% safe and you're producing nothing. So you need balanced priorities. If you do something wrong, what sort of judgment will fall on you? Is it extremely harsh? Is it all forgiving? Neither of the two is best. It should be flexible. You should do the judgments where you need to, but you should also be able to forgive somebody for simply making a mistake, an honest mistake, something they just didn't know. And on transparent reporting, it can go extreme where everything is hidden to complete over-reporting, where you just get so many reports, you can't actually manage it anymore. You need a balance between the two. And then lastly, this is a very famous one in safety management, is do you go blaming? Do you go over-analyzing? I know incidents 10 years later, we still don't know what the outcome of the incident investigations were, because it's still sub judice, we still don't know really. Then there's the other extreme of just simply blaming the operator, firing the operator or the pilot. And then what happens is you appoint a new one and the same incident reoccurs again. The challenge with this is you need to understand then what are the real feelings of these individuals. You're talking taboos here, like being scared, for example. And for that, a simple questionnaire with a Likert scale probably doesn't work very well. You've got to be careful how you phrase then the questions. Because as a result, I'm ending up with methods that are diverse from interviews, vignettes, questionnaires, and you've got to distinguish what you think about yourself and your colleagues. There's always a big difference there that we've seen in previous research. These are often in the workplace, and then from the outside looking in, incident reports are often more objective from the outside to help you explain why an incident happened. The safety specialists are also worthwhile to get information from. So I'm using different audiences, not only the workers and the employees, but also outside parties to assess what is the situation in this organization. In the case of Mr. Mann, he would say, my production bonus is my pride. I'm not going to report a minor incident. Nobody here does. And that bonus is important to me. So now you're trying to ask questions about that. It's hard to get the truth from your workers and see, are they really driven by the bonus to such an extent that they will keep on hiding these minor incidents, we're never learning anything. It takes a different intervention to address that. So we're sitting here eventually with a different type of scale from where we want to be in the middle of the scale, not on a Likert type scale, but rather say there's too little or there's too much, or are we sitting just at the right amount? The way we are controlling our actual behaviors when things go wrong. So I just want to start to get to this conclusion now, where we say safety management is changing from shallow compliance, tick box management system approach and procedures, and more procedures and more technology, to what we call now deep compliance and commitment. You have to mix that with a good dose of automation and artificial intelligence where that is available. The focus is clearly shifting to behavior, and especially deep behavior. What is actually your commitment? And my opportunity with this new data emerging in the last 2 or 3 years is to put this into a socio-technical systems model that you can actually see the dynamics. And it often yields now surprising results with the first few runs that I've done. In the past, we also had high-frequency incidents, lots of small-scale incidents. Today, we have low frequency. There's not many incidents happening, but what's starting to happen, they're becoming really large-scale, and there's less people. Like in the Boeing 737 MAX, you have 2 people in the cockpit only. And we're fully reliant on them to be the interface of all the beautiful technology we've put in there. So it's becoming really critical that those 2 people that increasingly, or they see less and less incidents happening, because we don't have many incidents. We're doing well. But when it does go amiss, they often don't know how to respond because they've just never experienced small-scale incidents. We've eliminated them. So the socio-technical model, we can identify now these weaknesses, emerging patterns. We can start training on these taboos, like the fears, like Mr. Man. If he's dead scared of that mine, what will you really do when there's an explosion? You have had 16 years of training. The training says you must walk slowly and carefully to the muster point, the gathering point where it's safe in the parking area. In reality, what do you do when there's an explosion? You run. And that's human nature. It's perfectly natural and normal. But we never have a conversation about that when we do safety training. We don't talk about these funny behaviors that we actually do when things go amiss. You may wonder why I've got the Zeus channel here. It was on my first slide too. It's interesting that Ever Given, that a month or 2 ago, got stuck in that channel, in the Zeus channel. And I like the sign here. That's the ship, by the way, that is sideways. It's blocking the channel, right? And there's what has happened there is, if you look at the incident investigations, I won't be surprised at all if in the end of the day, we've got the biggest container ship. It's one of the biggest container ships in the world. It's got all the technology on board. It got stuck in that channel. And the incident investigations, the preliminary ones I've seen, already start to suggest that 25 crew on that ship, they made mistakes. They were going too fast. There was pressure to get through that channel quickly. And it will end up being a human behavioral thing. You will fire the captain and you continue with the business as normal. And the question is, what can we do with these models to actually identify these variables that cause actual behaviors in the real workplace under real pressure? Can I better illustrate in my models, in training and in communication with our workers and our management? Why would you behave like that? And how do you prevent incidents of the large scale like these ones? Thank you very much.